Hey, what's up? Fantastic here. Glad that you're here. Maybe you're not here. Hey, today we are going to continue our journey through Epic React, and we're doing the Advanced React Hooks course, which I'm super excited about. I am a huge fan of useReducer. I know it's kind of a uh, contentious hook, I guess. So I'm excited to see what Epic React has in store for us on the useReducer hook, but then also kind of the you know use callback, use all the uses, use layout effect, lesser known one. But yeah, let's do it. It's lunchtime. I'm excited to hang out with you, and let's just dive right in. Let's just dive right in. Okay, so this is what we're working on today. There's my face. Hello, hello, hello. Um, Again, advanced React hooks in Epic React, and we're just going to go into this first exercise. Let's not beat around the bush today. Let's just jump right in. Okay, so we are in. Let's see. Is this use callback custom hook? Did I do that right? This order seems interesting. So we have, or am I just looking at the? Oh yeah, that's the next button. My bad, confusion already is not boding well for us. Okay, so let's read through what we got here. So useReducer's simple counter. Elaborate on our learnings from, okay. So background, React's use state hook can get you a really long way with React state management. That said, sometimes you want to separate the state logic from the components that make the state changes. In addition, if you have multiple elements of state that typically change together, then having an object that contains those elements of state can be quite helpful. And yes, we actually saw this the other day where we ended up putting in the just basic React state, we ended up putting a bunch of stuff in an object. And then I think we had some helper functions that kind of coordinated, or no, we just kind of had some functions that changed that state directly. Okay, so this is where useReducer comes in really handy. If you're familiar with Redux, then you'll feel really comfortable here. If not, then you have less to unlearn. uh, should be have a sound effect associated with it. The exercise will take you pretty deep into useReducer. Typically, you'll see useReducer with an object of state, but we're going to start by managing a single number, a count. Okay, no problem. We're doing this to ease you into useReducer and help you to learn the differences between conventional and actual APIs. Here, here's an example of using useReducer to manage value of a name in an input. Okay, so we have, let's see, so I'm gonna start here. We have our initial value, which is just Joe. We have a name reducer, which takes the previous name and the new name and then returns just the new name. Kind of a funny signature in this specific case, given that this doesn't do anything. Let's see, function, name input. So we have useReducer. So React useReducer. This side looks really similar to use state. So we're taking the state, which comes from the reducer, and then a update function. We are providing it the name reducer, which is defined right here, and then the initial state. Okay, no problems so far. And then handle change event. So we take the event and then set name with the event target name. Okay, so far, this is like largely indistinguishable from React use state, save for the fact that we're providing the reducer that's going to be used for it. Yeah, basically the same. We provide the initial state. So this would be gone, and this would be gone inside of a use state. Otherwise, it would be the same, I think. Okay, so one important thing to note here is that the reducer called name reducer above is called with two arguments, the current state and whatever it is that the dispatch function called set name above is called with. This is often called an action. Important verbiage so far. So exercise. We're going to cut off an example as we're going to start off as simple as possible with a counter component. useReducer is absolutely overkill for a counter component like ours, but for now, just focus on making this work with useReducer. Okay, let's do that. Here are two really helpful blog posts comparing useState and useReducer. So this one's Kent, another one from Kent. Okay, so we're going to start off. Okay, so then we're going to jump over here to our exercise. useReducer sample counter isolated. Okay, so if we want to see it, okay, we don't want to see the code, but we want to see how it works. Okay, so that's what it should do. That's what it does. Okay, so let's see what we're supposed to do. Replace useState with useReducer. React useReducer counter. Okay, cool. So, like I said earlier, so we have our initial count here. So it looks like that's, oh, okay. So it's being initialized with 0. Our steps. And so I guess we're going to add this here. So count reducer. It shouldn't matter where we define this, so I'm going to put it outside of our component. So count reducer is a, oh, I defined it like that. It's function. Chiano 40, welcome. Glad you're here. Thanks for being here. If you have any questions about what we're doing or why or when or how or who, feel free to ask them. I'm just going through the Epic React courses and, you know, learning some new stuff. Okay, so we have this function. I didn't define this right. So function, I'm going to need to take, let's see. So this one took the previous state. It was kind of unnecessary, except for, you know, we want to call it, let's see, reducer. Oh no, it's not, because we have to provide it that standard kind of signature, I think. So previous, what's it called? Nice. Yes, all of it, please. Yeah. Yep. Let's do it. Okay. Okay, cool. So we have this, let's see. So we're changing the count. So we'll call this previous count and new count, I guess. Let's just start with that, kind of borrowing from this example that we have over here. And then we're going to return the new count. So easy as that. And again, we can see specifically that this just is unused. No problems. That's fine. That's fine. Okay, cool. So count reducer initial count. So we have that. We're good there. So you can write the count reducer function so you don't have to make any changes to the next 2 lines of code. Remember, the first argument is called state, the current value of count, and the second argument is called new state. Oh shoot, Kent already did this for me. So that function is here, and my bad. And because it does use this step value, I do actually need to have it defined in here because step is a prop. So I wouldn't have it available here. No problem. So we have, let's see, what do we do? So first argument is going to be state, and then the second one will be new state. Okay. Alrighty, so increment. So this increment function is called, we have the previous state and the new state as is documented here. And then we are going to set count, which we do up here, to that. So you can write the count reducer functions. Okay. And then this will be, what's this going to be? New. Okay. Now I'm a little bit confused. Sorry, these instructions have me a little bit confused. Oh, thanks. Yeah, appreciate it. Just out of curiosity, if you're curious, I have a, what is it called? Sony A7 IV is the camera that I'm using through the cam link. And yeah, it's great. And then I have a 35 millimeter 1.8, which is pretty stellar. I'm a big fan of it. Big fan. So I got a little bit confused in in what I was doing. So I'm gonna try to pick up where I left off. Sometimes I get a little bit confused when we're kind of like kind of migrating code as opposed to like writing it from, you know, the beginning. Okay, so I'm gonna leave this there as a reference, which is kind of why I'm not like, it's like, it takes me a long time to really understand what's there, and then change it. Okay, so okay. So you can write the count reducer function so you don't have to make any changes to the next 2 lines. Okay, gotcha. Drew, what's up? Hey, good to see you. Glad that you're here. Even just coming by to say hi. Always a pleasure to see you. Yeah, it's a complex app. It's getting ridiculous, and it's neat too. Yeah, yeah, it's really interesting how. I mean, one thing that feels very real to me is that, you know, sometimes you. Oh my gosh, my buttons are all screwed up. Sometimes you feel very clever about something one day, and then like the next day you have to make a change to it and realize like, oh my gosh, like the way I did that actually made it way harder to do the thing that I'm trying to do now. And sometimes I feel that, like, especially with other people's code, but you know that like if you adjust it the way that makes you feel good that day, then you're going to be making the next person in line kind of hate you for it. So it's this never ending cycle of just, you know, terribleness. Um, okay, so I think I am understanding a little bit more now. So it says you can write the count reducer function so you don't have to make any changes to the next 2 lines of your code. Okay, so I was reading that initially that I was going to update this code, which clearly is not the case, given that saying that I can write this function without having to change the next 2 lines. So reading is extremely helpful. Something I will always be able to kind of learn. Okay, so we are going to write our function outside, and we'll call this state and new state, and we're going to return the new state. And then we pass that into count reducer. Okay, now this function is the one that we get from count reducer, and we're giving it the current count plus the step count. Now, it says that we don't have to make any changes to these, so we have to make sure that our arguments match up, and they don't currently, because I have this unused state. So that's going to come into state, but then we, you know, new state. So what the heck? Now, so if I'm going to make this work, I feel like I need to apply state is what I need to give it. So I'm going to see if that is like part of the lesson here. I did something so that this isn't showing count anymore. So initial count is 0. And then okay, that worked. Okay, so that screwed something up. Okay, let's see if we have any helpful errors. Console. Okay, so no errors that we can see. Default level. Yep. Okay. So the initial count. Oh, right. Use right. Duh. Helps if we use the right hook when we add values like this. Okay, cool. So if I do that, doesn't work. Okay, so let's change this to new state and see what happens. Okay, so that works. Okay, so when we call, so increment is going to call set count, and then it's calling this. So we just call it with the new state. We don't have to provide the old state. But then this reducer is going to be called with whatever we gave it as the second argument. And then this is kind of, we don't have access to that, or we don't need access to that in this signature. So, okay, cool. Good to know. Okay, does that all make sense? Any questions about that? Questions? Cool, cool, cool. Got a heart. Thanks, Shana. I like the purple heart. Okay, cool. So we got that so far. I think that is that's it. Okay, let's see what we have in terms of extra credit now. Accept the step as the action. Okay, I want to change things a bit to have this API. So count, change count, React to useReducer, count reducer, initial count. Okay, so that looks the same. Right? If I'm reading that correct. Oh, change count. Okay. So okay, so we'll change this to change count. Okay. How would you need to change a reducer to make this work? This one is just to show you that you can pass anything as the action. Oh, gotcha. Okay. Oh, so this is actually interesting. In terms of the example, I'm going to add this as a to-do so we can maybe add this in a pull request, which is extra credit versus set count. I'm curious if this shows up in the final version. So we look at extra credit to, yeah, we still have this set state concept here. Interesting. Okay, cool. Well, is what it is. Okay, so what they're asking us to do is change this to just take step. And this is going to lead us into our previous state type thing. So if we take step, we're going to get it in new state. And we actually probably don't want to call this new state. This will just be, I don't know, value. It's a terrible name. But actually, let me do it this way. So we're going to take this and we're going to put it here, right? Like that's effectively what we're doing. is return the previous state plus the, actually, hold on a second. My daughter's asking me right now if they can have candy. Sorry for that. Just want to make sure it wasn't an emergency. Okay, so sorry. State and step. And so then we're just going to change this to step. Now, this is probably not the best idea, but it is what it is in terms of just kind of showing how we're moving this code. And so then we're going to take this and we're just going to provide step. So we've moved what was here up here, so we can just provide step, and then step, we'll do that. Sorry about that. Yeah, I think maybe because it was like linked into the computer, but yeah, my bad. Hopefully it doesn't happen again. I thought that I had DND, but maybe because, you know, it's one of my kids, they just, you know, come right through, I guess. Apologies. Okay, let's see. Okay, so it looks like that still worked. We have no problems there. We just move that inside there. So that's extra credit number 2. Okay, so we got that. That's looking good. So simulate set state with an object. So remember, this.setState from class components. If not, lucky you. Either way, let's see if you can figure out how to make the state updater dispatch function behave in a way similar to change our state to an object where we have count is 0 inside of this state object. And then calling the state updater with an object which merges with the current state. So here's how I want things to look now. Okay, so I have set state. Where is the, oh, so we have state. Okay, so these things kind of change again. So we're gonna change this to state. We'll have this be set state. Okay, and then count reducer is the same. And then initial count also, no, not the same. It's going to be like this, and then count like that. Okay, so now we have, now we have an object here. So that right there is our objects. And then we're going to destructure count off of state. So count, const count equals state. Okay, these errors. And then increment set state of count. Okay, so now we're changing this back to what it was before. So this will be set state, a lot of code motion here. And we'll say the new count, or the new object, is going to include count, which will be derived from count plus step. Okay, so now we need to update that function, our reducer function, to have this signature again, which will be the previous state, and then the current or next state, I guess. And then I think this is just going to return next state, because effectively we're already doing the math on this, and we're just taking this new object and returning a new state. So let's see if that works. It does. Great. Okay. How do you need to change the reducer to make this work? Okay, so I think we did that. We kind of put it back to what it was before, because now all of this object is being managed inside of the counter. Okay. Simulate set state with an object or function. Okay. This dot set state, can also accept a function. So let's add support for that with our simulate set state function. So see if you can figure out how to make your reducer support both the object as the last extra credit in the last extra credit, as well as a function callback. Okay, so we're gonna have this, which we currently have. Let's just kind of, okay. Took me forever to realize that I should just close that. Okay, so we have, okay, so that looks the same. We have React, defining React useReducer, count reducer. Okay, initial state, we got that. Yep. This looks the same, but then this line will be different. So here, what we want to do is we want to pass the, so we want to take the current state. So this is an object, assuming, and we want to return, but taking this value from the current state dot count. Okay, so if we look at this, what we need to do is we need to call a function with the current state so that then this function here can use it to manipulate the next count. But we want to do it in such a way that we can keep the object syntax. So right here. So I guess the way I would do this is, you know, if type of previous state equals object. Needs a J. We're gonna return. Let's see. Oh no, that's the state that we're in, right? So, okay. And then let's do this. So if type of function, then we're going to return a call of previous state with the, oh no, sorry. We're going to, this is next state. Because previous state is always going to be an object. It's not going to be a function. So if next state, the one that we get from this function call right here is an object, then we'll just return next state. If, let's see, if type of next state is a function, we're going to call next state with previous state. Okay. And then I guess in this case, we would like throw some kind of error, like, okay, so if we get like a string or something like that, then that would be invalid. So, you know, string or a number or an array. Okay, so this should still work. I should have made a copy of the original one. I'm going to refresh that just in case. Yes. Okay, cool. This does still work. Now, just to make sure that this is updating properly, let's do step +2. So this should be 15. Nope. Can I do that actually? So do I need to do that? Can I do that? That seems wild. There we go. 2, 4, 6, 8, 10. Okay, cool. All right. Okay, cool. So we're kind of zipping through some of this extra credit. Any questions so far? Any questions so far? Nothing too out of the ordinary. Let me kind of check that against, which one was this? Object or function number 3. I want to check this answer against what we have here. So uses an interesting syntax here, significantly different than what I did. So if I close this, we can kind of see what's going on. So I used this if statement, or these if statements. This one is cooler looking for sure, but it's always going to return an object, and that object will have all of the previous state. Okay. And then if type of action, so this guy right here is a function, then we'll call that, or it'll just return action. Oh, gotcha. Okay, so we're always returning the state object, but if, oh, right. Okay, so in my case, I'm not actually merging the objects, so that is problematic. So I would have to return a next object. No. And so I was working under the assumption that this data will never change. So it's always going to be just that one property, counter 0. But the value of having these objects is the fact that you can add more properties to them. And so if I just returned the next object, it would, anytime I tried to update this object, it would just obliterate everything else and just put the count 0 in it. So if I had any other values in there, that would be extremely problematic. Okay, cool. So that's what we need to do there. And then in this case, I think we're still fine because we're requiring you to do that mutation, I guess. Yeah, so we're giving you all of the current state, and if you return something that obliterates all of the rest of the state, then I guess that was intentional, theoretically. You know, like a reset button where you want all of those fields reset, I guess. Yeah. There be dragons. Okay, so I think that this is appropriate now. I think we're seeing. Actually, no, it's not. In this case, both times it's going to return an object, and in my case, it's not. So we're actually going to spread out that. Okay. Now I want to double check this and make sure this is actually doing what I think it's supposed to be doing. So we're going to have an object version of this. Now so we'll start with the object version. That's using the local value of this state right here. Okay, so that seems to work. No problems. Now let's do the function version. Looks like it's working, no problems as well. Okay, cool. Interesting. I'm glad I opened that up because that was very much incorrect, or not incorrect for this example, but it was incorrect for kind of the intention of using useReducer and like having a whole object here. So, okay, so number 4, traditional dispatch object with a type and a switch statement. Cool. Okay, now we can finally see what most people do conventionally, mostly thanks to Redux. Update your reducer so I can do this. State and dispatch. Okay, so those are going to change. Reducer. Oh, no, that's here. State and then dispatch. Okay. Count. that's the same. Increment dispatch, and then we're going to give it a type. Okay, so for here, dispatch. And then we are not using a function here. I'm going to say dispatch type increment incremente increment, and let's see, and then step. Okay, now because of this object syntax, it's going to be 1 here. So type increment and then step equals 1. Okay, this is just shorthand for step equals step, like that. Okay, no problems there. Other notes, lazy initialization. This one's not an extra credit, but sometimes lazy initialization can be useful. So here's how you would do that with our original hook API init initialize state from props. Gotcha. So it would provide the reducer, the initial state, and then an initializer that would kind of return those objects. Okay, no problem. That's not part of this assignment though, so I want to get this going. Now, these conditions are really just going to change, and I could use, it says something about it using a reducer, right? This and a switch statement. Yeah, okay, so let's do that. Let's just use a switch. I never know how to do that, so I always use VS Code to tell me how to do that. We're looking at this. We're going to switch on the type, I think, of action. So type increment. So this will be action.type. Okay, and then the first value that we're going to use is increment, that string that we did. We need to change this to action, which is now an object. And we can use breaks, but because we're going to be doing early returns, we don't technically need them. Sorry, another request. So we don't technically need them. We're going to run a return. And then we can move these up. So if we want to increment, we're just going to do this. I think it's okay that maybe we're... yeah, I'm going to hold on to this just in case we need it later. Like if we want to kind of provide the function option, but I think that that's maybe unnecessary now. I'll double check. So here we're going to, if the action type is increment, we're going to return all of the previous state. And then we're going to say count is previous state dot count plus step. Oh, action dot step, right? Yeah, okay, cool. So let's try that. That seems to work. Ermagerd, Lernsterv. Good to see you, Anthony. Always good to see you. Okay, so here we go. That seems to work. Everything is in order. Let's see. Do we want to do the lazy initialization one? I mean, I guess we could. It's not really It's not really a lot that I mean, I think that we're going to come across it again. But let's read about it. So if you pass a third function argument to useReducer, it passes the second argument to that function and uses the return value for the initial state. Okay, so let's see. So props.initialState and then init. And so this init function will actually take these props in it. And so I guess we can use those, but it doesn't look like it's using any of those values, which is kind of an interesting example here. This could be useful if our init function read into local storage or something else that we wouldn't want to happen on every render. Okay, cool. So this harkens back to that every render concept of set state, where you can provide it with a function so that it doesn't do that initialization every time. It's the same mechanism as that, which is cool. So the full useReducer API, if you're into TypeScript, here's some type definitions for useReducer. Thanks, Trey's blog post. Let's open that up real quick. Please don't spend too much time reading through this, by the way. Okay, so, oh, right. In a different browser. So use TypeScript. So Trey Hoffine. Use TypeScript, a complete guide to React hooks and TypeScript. Oh, interesting. Okay, so this is a big guy, big boy. useReducer. Oh, interesting. Doesn't self-reference. Use state with TypeScript. Okay, so we need to use reducer with TypeScript. Okay, so that's what we have here, and these types. Okay, so here we would have action types, increment, decrement, iState. So the interface for state would be count, which is a number. Okay, no problem. This is very C#. Yeah, one of those. But those, like that I prefix, I do not like prefix based naming. Like, was it Hungarian notation or something like that? Not a fan. So type, action type, payload count. Okay, so type. Okay, so this is going to be, so type can be any of our action types, which will be increment or decrement, and the payload is going to be an object which has the shape of count number, which is interesting because it seems like this interface could be applied here. I'm not sure why we're duping that. I don't know. Interesting. Const initial state, iState, blah. Count 0. Okay, so here's probably the guts of it. So there's a React reducer type, and so we will use iState and iAction for that. And then there we go. Case action increment. So this is really cool because we're actually using this via this enum. I know enums are a little bit like a contentious topic in TypeScript. I don't know. I mean, I guess I don't have a strong opinion about it, but I guess it is good to know enums are a contentious topic. Some people find them useless. Obviously, some people find them useful. So pick your poison. And then, yeah, so we're returning this, and we should be fine. There are non-contentious topics in TypeScript? I guess not. I feel like all typed languages is just... I mean, this is kind of like the nature of like anything prescriptive, I guess, like religions, you know. It's like you come up with all of these, like, really, you come up with these laws, right, from which you have to live by, and then they're just naturally segregationalist. It's like everyone builds up their own fences so that they can feel comfortable in their own, land or whatever, is what it is. Okay, so user function can utilize the following types. Okay, I'm not going to go again. It says not to go too deep into this, and so I'm not going to go too deep into this. Okay, so I guess please don't get too much time on this. So type dispatch a value void. Okay. Okay, so these are the type. Okay, gotcha. useReducer is pretty versatile. The key takeaways here is that while conventions are useful, understanding the API and its compatibilities are more important, which is correct. The value of useReducer is that you can do whatever you want in here, which is cool. It doesn't have to be fancy. I think that, there are conventions like this, switch statement and the action type, but even implementing that, we could have used if statements if we wanted to. We don't have to use switch. I think people do use it by convention just because it's much clearer that your states are covered when they're inside of this switch case. Again, just convention really, because, as long as it returns the same thing, doesn't really matter what's on the inside, unless performance is a really big problem, but then it could look way different if you're trying to optimize for that. All right, so we have useCallback. How are we doing on time? I think I started around 1-ish, so yeah, we still got a little bit of time. I usually go for about like 90 minutes. Okay, useCallback custom hook. Background, memoization in general. Memoization, a performance optimization technique which eliminates the need to recompute a value for a given input by storing the original computation and returning that stored value when the same input is provided. Memoization is a form of caching. Here's a simple implementation. So const values, add 1, number. Oh, this is interesting. So this is TypeScript. Huh. Curious how that snuck in there. If values of number equals undefined. Okay. Interesting. I would have, oh yeah, type of. So it is undefined. Got it. Okay. Value of number equals number plus 1. Here's the computation. Return values of number. Okay. One other aspect of them is like, okay, interesting. Yes. Okay. Gotcha. So we're storing this kind of like intermediate value, and then we're saying if there is not a 1 inside of this value, if there's not a 1 key, then do the math. Otherwise, just return the value of the 1 key. Okay, yep. So instead of doing the computation, we're just accessing something that we previously computed. One other aspect of memoization is value or referential equality. For example, dog 1 equals new dog Sam, dog 2 equals new dog Sam, console.log dog 1 equals dog 2 is false because they're two different objects references. I guess these would be, I don't know. It would depend how they're implemented, I guess. Even though these two dogs have the same name, they are not the same. However, we can use memoization to get the same dog. Const dogs function get dog name string. If dogs of name, we're seeing that same pattern here where we're just kind of creating this object, and we say if there is not a Sam, then we're going to make a new dog named Sam and then return that dog named Sam. But then that second time, we will see like, oh, hey, there is a Sam in this dog's object. It's not undefined, so now we're just going to return that. You might have noticed that our memoization example looks very similar. Memoization is something you can implement as a generic abstraction. Okay, so we're starting to see TypeScript here, which is pretty cool. Memoize, argtype, return value. Takes callback with the argtype, with the arg from the argtype, and yeah, so cache, record, argtype, return value. So that's going to be an object, return function, memoized, arg. So same thing with types. But this is just a generic memoize function. So then we can memoize anything. So as opposed to having this be just a number, we can do this with any type and then do this. Cool. So we would have in this memoize function, so in this cache, we would have a 1 record, and then we would also have a Sam dog record. And it doesn't really matter what those keys are, except for the fact that if it finds one of those keys again, it's going to return that object. Our abstraction only supports 1 argument. If you want to make it work for any type, number, or of arguments, knock yourself out. Memoization in React. Luckily, in React, we have to implement memoization. We don't have to implement a memoization abstraction. They made 2 for us: use memo and use callback. For more on this, read memoization and React. Okay, that's Epic React dev post. You know the dependency list of useEffect? Here's a quick refresher. React useEffect takes a function. It uses count as one of its inputs, window local storage, set item with the key of count using the value of count. This is the dependency list or inputs right here. So that means that if they don't change, this is caching that we've seen up to this point. If that value doesn't change, this function doesn't run. If it does change, the function does run. Remember, the dependency list is how React knows whether to call your callback. And if you don't provide one, then React will call your callback every render. It does this to ensure that the side effects you are performing in the callback doesn't get out of sync with the state of the application. But what happens if I use a function in a callback? Okay, so let's see this. Update local storage. So we have a function. So same function that we had up here. We're going to call it what goes in the dependency list. Okay. What goes in the dependency list? I mean, I would assume count because it was there before. Seems like it should still be there, I guess. We could just put the count in the dependency list and that would actually accidentally work. Interesting. But what would happen if one day someone were to change update local storage? Okay, update local storage. Okay, so we have a dynamic key. Would you remember to update the dependency list to include the key? I mean, I would have the lint rule be there, and I guess maybe it wouldn't catch it, actually. I don't know. That's interesting. Okay. Curious if anyone has a case like that, and if the lint rule caught it for them. Hopefully we would, but this can be a pain to keep track of dependencies, especially if the function that you're using in your useEffect callback is coming to us from props, in the case of a custom component or arguments. In the case of a custom hook, you don't use ESLint at all, like not even for the React rules. I find that that's the one that's most helpful for. I can't say that I really recommend any other ESLint rules, but I know Storybook 2 also has some ESLint rules for writing stories. I feel like it's really helpful from the library side. I generally don't find it helpful now that we have Prettier, but it does seem like libraries will often provide some rules for ESLint that may be lesser known. Yeah, probably should for the React rules. Yeah, I do find it helpful, honestly. Yeah, library stuff is kind of the only thing that I really want to use ESLint for. Everything else feels not great. And so I am grateful for ESLint for that reason. Okay, instead it would be much easier if we could just put the function itself in the dependencies list. I gotta say, I have been really impressed with this course in how Kent gets to the idea. I think that sometimes it can feel a little bit like, why did I do that? I'm not really sure why I did that. Like, why are we talking about this? This seems complicated. But like when you get there, there's like a payoff. And I feel like this payoff, like right now, it's like we're talking about caching. Okay, use effect. Like, I'm not really sure. Like, okay, like I see that it's caching, but like, I don't really understand. But then like you get to, you get here, and like it's like, oh, okay, here it comes together. Like, okay, we got this thing. I don't want to have to manage it here when it's here. So what do I do? Oh, great. That's where, these memoization tools are going to come in. Use callback. Awesome. It was maybe a sultry sound effect for the head exploding. Okay. Window. Okay. Count. Update local storage. Okay, I was just so excited for a second. I'm just standing Kent for a second and got lost. But this can be a pain to keep track of, especially if the function that we're using in our use effect callback is coming to us from props. In the case of yep. Instead, we would like a much easier if we could just put the function itself in the dependency list. Okay, so update function local storage. Okay, yep. Now we're just putting update local storage in there. The problem with that, though, is it will trigger the use effect to run every render. This is because use local storage is defined inside the component function body, so it's reinitialized every time. So this function, because it is inside, like this is inside a bigger React component, is created every time the component runs. So, which means it changes every time, which means, you guessed it, our use effect callback will be called every render. This is the problem use callback solves. Like use callback. And here's how it solves it. Okay, so update local storage, React use callback. So now we have this wrapped inside of use callback, and then here we can put the count. So yep, it's a dependency list, which is really cool to see these composed, right? So this uses count, and so we have used use callback on count, which is super cool. And then here, if this is what we're tracking, this function, so should that ever change, then we'll do that. Now theoretically, it is changing every time, so I don't think that's really doing anything in this case. But so this is running every time. Oh no, because we're using callback, so it won't change every time unless we like change the function, I think, or some of the arguments change. Yes, it will only become sorry, figuring this out in real time. Yes, it will only become new if count changes. So we only get a new function if count changes. Whew. Thick. Okay. What the hell, man? It's so funny reading and thinking through this, and then like waiting for the things that I know to like catch up with my mouth. Super fun. what that does is we pass React a function and React gives that same function back to us. Sounds kind of useless, right? Imagine. This is not how React actually implements this function. We're just imagining. So function use callback. Okay. So it's like, oh, okay, we give it a callback and it just returns the thing that we gave it. But there's a catch. On subsequent renders, if the element in the dependency list are unchanged, instead of giving the same function back that we gave to it, React will give us the same function it gave us last time. So imagine, so we have last callback here, and then callback depth. So if depths change, then we're going to say the last callback equals the new callback and return the callback. Otherwise, return the last callback. So if the dependencies don't change, just use the last one that we stored. So while we still create a new function every time, okay, yes, this is where big brain here realized what was going on. Yes, if we create a new function every time to pass the callback, React only gives us the new one if our dependency list changes. So it is a new function every time, but we only get a new one when our yes. Oh my gosh. In this exercise, we're going to be using useCallback, but useCallback is just a shortcut to using useMemo for functions. Okay, so that is kind of important information, kind of which one uses which. And so useMemo and useCallback, it seems like useMemo is the kind of like lower level one. So let's look at this. This is a long lesson, by the way. Curious how much of this we'll get through. It looks like there's a lot of exercises too. Okay. Back to implementation. Use memo version, update local storage. So React use memo. So this is like this double function thing. Use callback saves us from this annoying double arrow function thing. This annoying double arrow function thing. The use callback version just uses the kind of one callback. Cool. Common question with this is, why don't we just wrap every function and use callback? You can read about this in my blog post, when to use useMemo and use callback. Okay. I'm not going to go out to the posts for now. If the concept of a closure is new or confusing to you, give this a read. Okay, oh, this one's on MDN closures. Closures are one of the reasons it's important to keep dependency lists correct. Okay, people tend to find exercise. People tend to find this exercise more difficult, so I strongly advise spending some time understanding how the code works before making any changes. Also, one thing to keep in mind that React hooks are a great foundation upon which to build libraries, and many have been built. For that reason, you don't often need to go this deep into making custom hooks. So if you find this one isn't clicking for you, know that you're learning, and when you do face a situation when you need to use this knowledge, you'll be able to come back and it will click right into place. So Peter, the project manager, told us that we've got more features coming our way that will require managing async state. Sounds like a pretty awesome project manager to tell you that right up front. Props, Peter. We've already got some code for our Pokemon lookup feature. If you've gone from the React Hooks workshop already, then this should be familiar. If not, spend some time playing with the app to get up to speed on what we're dealing with here. We're going to refactor out the async logic so we can reuse this in other areas of the app. So our job is to extract the logic from Pokemon info component into a custom and generic async hook. In the process, you'll find you need to do some fancy things with dependencies. Dependency arrays are the biggest challenge to deal with when making custom hooks. In this part of the exercise, we don't need to use callback. We'll add it in the extra credits. It's important that you work on this refactor first so you can appreciate the value of useCallback provides in certain circumstances. Okay, cool. So this is a lot of information. Appreciate it. Okay, so mount component, unmount component. Okay, so let's just play around with this for a second. We can look at Pikachu, hit submit, we see a loading state, and then we get Pikachu. If we change this to just P, we are going to hit submit, get an error presumably. Yes, unsupported Pokemon, P, try Charizard. Okay, so we clear that out and hit Charizard. Actually, I'm going to do that again and then see. I think we were able to fix this in the final version and then resubmit. Yep, okay, cool. Perfect, no problems. No problems. Okay, now let's look at the final and see how things differ. So Pikachu, and it's just I guess it's just a refactoring, right? Yeah. So I don't think there should be anything different. Okay, cool, no problem. Let's now take a look at the components. So we're going to close this up. We're going to go to exercise 2. Great. Okay, so this is okay. Let's see. This is going to be our generic async reducer. Okay, so what do we have? We take some previous state and action. If the action type is pending, then we're going to return this state. So no Pokemon, no error with a status of pending. If it's resolved, we'll return resolved. The Pokemon will be the Pokemon that we get from the action, and there's no error. Rejected, we'll have an error, no Pokemon, and the status of rejected. And screwed up one last thing. And then default, we will throw an error saying that it was unable to handle the action. Okay, any questions so far? I know we've just been kind of like reading a lot, and hopefully you got something from that. But let me know if you didn't. Okay, so move all the code between the lines into a new async function. Okay, so I'm assuming, yeah. Okay, so we have a beginning and an end. This all needs to go into an async function. Okay, look below to see how the async hook is supposed to be called. Async hook. Okay. So what is it? If there's no Pokemon, return dispatch type pending. Okay, so this is all in a use effect. Okay, look below to see how it's supposed to be called. Okay, so we should be seeing some dispatch functions, I think. Pokemon info, Pokemon form, on handle submit, set Pokemon with the new Pokemon. Okay. Handle reset. Okay, so it's just, we're just calling with a new Pokemon. Okay. So this is just managing the set Pokemon name. Pokemon info. Oh, okay, gotcha. And then the Pokemon info component is just taking the Pokemon name. Got it. Okay, cool. So, okay. Okay, got it. So we're just calling it with a Pokemon name is all. Okay, cool. So I think I understand, maybe. Okay, cool. If you want some help, here's a function signature, or delete this. Comment really quick if you don't want the spoiler. Okay. Okay, so we have, this is our generic reducer. I do want the spoiler. Okay, function, use async callback, initial state dependencies, code in here. Okay, start. So dispatch useReducer, Pokemon info, state. So if, okay, Pokemon info. If we have a Pokemon name, we're going to set to pending, otherwise idle. Okay, so as soon as we hit submit, we're going to set this status to pending, otherwise it's idle. We don't have a Pokemon and we don't have an error at this point. We're just pending. Okay, this will need to be data instead of Pokemon. Okay. Still a little bit confused as to what we're supposed to be doing, but we'll get there. Let's see, this early exit, this first early exit bit is a little tricky, so let me give you a hint. Promise async callback. If promise return, then can dispatch handle promise. Okay. Gotcha. Okay, so we're going to move all of this code into a new use async function. Okay, gotcha. Okay. Okay, gotcha. Okay, so right now, all of it is in this use effect, which is inside of the component. And we want to be able to not have that in the component. But first, we're going to do it by defining an async function that lives inside the component. So I think this goes here, right? Which is going to kind of disassociate a handful of values. So like right here, we don't have any state because we've hidden it. Okay. Got it. Okay. Okay, so looking at this again, so that's that, and then it says look below to see how the use sync API is intended to be called. Here you'll use the new async hook. We're writing const async if Pokemon return, return fetch Pokemon. Okay, initial state. Okay, this is interesting. I'm not sure from which end to attack this. Dang it. I am running out of time. Shoot. Is what it is. Unfortunately, I do have kind of like a hard cutoff today, but it's okay. All right. Let's see how far we can get in the next 13 minutes. So here's how we use the async hook. I'm going to start here because I think sometimes starting from the call helps me out. So we're going to create state, which we'll then use. So that fixes that reference. Async, if Pokemon return, return fetch Pokemon otherwise. So we're going to give it the initial state. Can't remember. Do we have a shared initial state? I don't think so. So it should be, definitely should be idle. We shouldn't have a Pokemon, I don't think. So let's just grab this. Nope, that's the use effect. Okay, right here. Okay, so it's going to be state idle, Pokemon null, error null. This will change the Pokemon to data. It's interesting. This will change from Pokemon to data. I'm assuming they mean this. Okay, I'm not going to worry about that right now. Okay. Okay, so now let's look at this. So we have async callback, our initial state, and our dependencies. Okay, and when we're calling that, we have our dependencies. That's what they look like here, our initial state right here, and then our async callback. So if there's no Pokemon name, return, and which will return idle. If there is a Pokemon name, fetch the Pokemon. Okay. Now we're getting this. Why is it saying that? So React Hook's use effect is an unnecessary dependency. Okay. React useReducer Pokemon info. Okay, so we're going to use a reducer and we're going to use the Pokemon info reducer that we have here. Okay. I'm not sure why there's like so many places that are replace Pokemon with data. Oh, I mean, I guess it's to make it generic, right? Okay, well, I'm not super worried about that yet. It can be whatever it wants, and we can just generally refactor it later. Okay. The first early exit bit is a little tricky, so let me give you a hint. So const promise is an async callback. So if there's no promise, return. Async callback. Okay. Then you can dispatch the handle the promise, etc. So if not Pokemon name, return dispatch type pending. Okay, yes. Fetch Pokemon. Now we don't have access to fetch Pokemon anymore. Fetch Pokemon is part of this async function that we're getting. So we're going to call async callback with the Pokemon name and then do what we were doing before. You'll accept dependencies as an array and pass that in here. Okay, so here we have dependencies, so we can just change this to dependencies. was passed dependencies list that is not an array literal. Okay, so how are we not? Okay, so we are passing in an array with Pokemon to use async. Oh, missing async callback. So I can pass in an array of these things too? I've not actually done that. So because of the limitations of ESLint, you'll need to ignore the React hooks exhaustive depths rule. We'll fix this in extra credit. Okay, got it. Got it. So it is complaining about not having async callback in there, not the fact that this is not an array literal. This means you can't statistically verify whether you've passed the correct dependencies. Okay, cool. So actually, let me just see this. I want to make sure. Dependencies. Okay, so we do have an array of 0. Yeah, okay, Charizard. Okay, so that is coming in. Okay, cool, no problem. Perfect. Okay, so we have all that in place. Does it work? Will it blend? Okay, it seems to. Cool. Cannot destructure property Pokemon off state as it is undefined. Okay, so that's problematic. So initial state, we need to use initial state somewhere. So, oh, right. We have to return now the return whatever this expects. So it'll here, I'll just copy this. Oops. So we're going to return an object with the Pokemon. Actually, we can just return our state, right? Yep. Because that's all on state. And then are we not using initial state? It looks like we're not. So we're going to use reducer. Shoot, I can't remember. I think. So we're going to pass it props, but then we have this initial state. Use async. Do we have an initial state? We are calling it with an initial state. So here, we could use initial state instead. But yeah, so let's do this. Let's come back to this one. Because it could, yeah. Okay, so, and then this will be, okay, and then we'll set that status with the value of Pokemon that we get. Okay, so submit a Pokemon, that fixes that. So P, we get an error. Still see our loading. Yep, okay, and then if we go to Pikachu, Cool. We do see Pikachu. Okay, cool. Perfect. I think we got that. And then I guess technically we just need to change this to data. So it's, it is generic, I guess. Let's see. Failed to load resource from the server. Spine. Okay, yay. Unsupported Pokemon. Okay, cool. So this is throwing, I think we expect those errors because it's, throwing them to get the error boundary to enact. Or here, wait, let's double check. Okay, so we get Pikachu, submit, no problems there. Pikachu. Okay, so not found. Unsupported Pikachu, try Mewtwo. Console, oops. Okay. I wonder if that's part of the error boundary. So if I go here, hit F12, does the error boundary log? I guess that's part of library code. That's fine. Okay, so above components. So yeah, let's see, where did this? So yeah, throw error rejected. Okay, cool, perfect. Okay, so I think we did it. Now, assuming, let's check out the final thing. Oh, gotta leave. Check out the final thing. So for number 2, just in case, see how we did. So number 2, wish there was a way to scroll these together. Maybe there is. Oops. Okay. Oh gosh. Is Command B not the, sidebar thing? Confusion. Okay, so async. Okay, so we have all this stuff. We borrowed that, so clearly that's correct. Okay, this all looks right. Data. Okay, dependencies. Pokemon async. Okay, all of that stuff didn't change. And then what do we have? That didn't change. Okay, cool. So I think that we're good. $35. Yeah. This is the final, and then, oh, look, I was looking at 2 finals. Okay, cool. Yes, of course, those are gonna match each other. They're the same file. Let's see. Okay, so there's all these comments removed. Okay, so that's the same. Again, we're using Pokemon, not data, not generic, truly, but is what it is. Okay, so Pokemon async. Okay, so we have this function, we have this dispatcher thing. So it looks like we're not actually using the, okay, cool. So we're just merging the initial state values onto what was already there, which is, presumably better than what I had, assuming that they're not provided thoroughly. Use effects. Okay, so that is all of that code. Dispatch, the Pokemon data, and then dependencies and return state. Okay, yep, that's looking right. And let's see, let's look at this use sync call. So that all stays the same. And then we are doing that. Okay. Oh, and then because we are for sure we're making sure that all of those right values are provided. up above. We don't need to for sure provide them here. We can just, if we have the Pokemon name, do that. Okay, yep, that looks great. No problems. Okay, and then the rest we remained untouched. Okay, cool. That was quite a bit. It's quite a bit. I do like this lesson. I think this is a little bit challenging just because there's so much that needs to change. I think this lesson was it's a little bit challenging because there's like all of these pieces need to change. And I think maybe some numbers, like if I was going to do this again, I think maybe some numbers would be helpful, especially changing it to like data as well. That part of it feels like a mechanical process. Maybe that's intentional. Again, like maybe this is intentional. I haven't been able to go through the additional exercises, so maybe we'll see kind of how that was intentional in, you know, the extra credit number 1 and extra credit number 2. But it does seem, yeah, like this kind of mechanical change that isn't strictly necessary, as we just left at Pokemon. So that's it. We got through, you know, a lesson and I guess a half, I'm gonna call it. A lot of reading in this one, but it's good. I think that understanding useCallback and relating it to useEffect is really important. I think in one of the videos, in one of the streams, that was actually the question that people had, was like, how does this relate to, you know, useCallback, you know, for this, how does this useEffect inputs relate to useCallback? And I think we were able to see in this lesson how it does relate, which is, you know, when we're wrapping functions and not using some kind of effect, or synchronizing state, as a lot of people like to say with effects, then we can use useCallback for that. But the API is effectively the same where any of our dependencies, we just add to that dependencies array and track them. So that's it. I'll probably do another one of these tomorrow where we'll continue on with the lessons that we didn't get to today. If you're still hanging around, thanks for being here. Thanks for the people who, you know, said hi. And I'll see you in the next one. Yeah, that's it. Thanks for being here. Hopefully I'm actually going to post another video on Thursday. I'm just talking about some kind of like, you know, high level dev creative stuff. So I will see you then. Peace. Bye.